Okay, so we're going to have a look at some periodic trends, that is trends that you can find in the periodic table. Okay, so why don't we start by looking at groups and periods. Okay, so a group is a vertical column from top to bottom. Okay, and the group number tells us the number of electrons in the outer shell. So we have group 1, group 2, group 3 and group 4, group 5, group 6, group 7 and group 8. So that means that group 1 has 1 electron in the outer shell, group 2 has 2 electrons, and so on until we get to group 8, which have full outer shells. Okay? Now a period is from left to right, and the period number is the number of occupied energy levels. So this is period 1, 2, 3, 4, 5, 6, 7. Okay, so if we choose an element, why not choose aluminium here? So aluminium is in group 3, so it has 3 electrons in the outer shell, and it's in period 3. That means it has 3 occupied energy levels. Okay, look at another one, for example, oxygen. Oxygen is in group 6. It has 6 electrons in the outer shell. It's in period 2, so that means that it has 2 occupied energy levels. Okay. Right, now the trends we're going to look at are atomic radius, which is the size of the atom, ionization energy, which is the energy required to remove the outermost valence electron from a gaseous atom, and nuclear charge. Nuclear charge is the number of protons in the nucleus, and the trend is it increases by 1 from left to right. So let's have a closer look at atomic radius. Okay, so you can see here as you go down here, okay, as you go down here, the atomic radius is increasing. As you go from left to right, the atomic radius is decreasing. They're getting smaller as you go left to right, and they're getting bigger top to bottom. So let's try and explain that trend, shall we? So the trend is atomic radius increases down a group. But why does it do that? Well, obviously, as you go down a group, you've got more occupied energy levels. And the valence electrons, which are the outermost electrons, are further away from the nucleus. Okay? Atomic radius decreases across a period from left to right. Why is that? Well, you've got increasing nuclear charge, and the electrons are in the same main energy level. Okay, level is missing there, and the electrons are pulled in tighter. So I'm going to put level on the end there. The electrons are pulled in tighter, which gives you a smaller atom. Okay, so those are the reasons for the trends in atomic radius. Next is ionization energy, which is the energy required to remove the outermost electron in a gaseous atom. Okay, so here we have helium, neon, and argon. They're noble gases, and they have very high ionization energies. Okay, because they have full outer shell of electrons. Okay, and that makes it difficult to remove the electron. Now at the bottom here we have the group 1. Okay, the group 1 metals. So this one is lithium, and here we have sodium, which is Na. They have very low, okay, very low ionization energies, because they only have 1 electron in the outer shell. Okay, and that electron is quite far from the nucleus, and it's also shielded by the inner electron, so that's quite easy to remove. Okay, so let's have a look at the general trends. Ionization energy decreases down a group. Why is that? Well, the valence electrons are further from the pull of the nucleus. Okay, remember the nucleus is positive and the electrons are negative. Okay, so they attract each other. Second point, weaker electrostatic attraction. Now remember, the electrostatic attraction is just the attraction between positive and negative. Okay, so you get a weaker electrostatic attraction between the nucleus and valence electrons. Therefore, it's easier or less energy is required to remove the outer electron. Okay. Now, why does it increase across a period? Well, we have increasing nuclear charge, okay, and we have decreasing atomic radius. So that means that the valence electrons are held more tightly. Therefore, more energy is required to remove them. Okay, so there's the trend for atomic radius and ionization energy.